Welcome back, guys. Uh, in the last video, we discussed the band theory and we saw the energy bands in conductors, insulators, and semiconductors. And we came to know that semiconductors acts as insulators at low temperatures, and as we approach room temperature, it behaves as a conductor. But how does this happen? Now today we will account for this behavior. Now for that we have to look at the molecular structure of a semiconductor. Let us consider a silicon atom with atomic number 14, and its electronic configuration can be written as 1s2, 2s2, 2p6, 3s2, and 3p2. That means there are 4 electrons in the outermost shell. So now silicon atoms will make use of this 4 electrons to bond with other silicon atoms to form a solid, as you can see here. Now this central silicon atom has 4 electrons, and the adjacent silicon atoms will share their electrons, indicated by this yellow dot. So now the central silicon atom is stable as it has 8 electrons, and similarly all the other silicon atoms will become stable by forming a covalent bond with the adjacent silicon atoms. Okay, this is at low temperature, and as we approach room temperature, as the electrons get thermally excited, they may leave their site. And they create a vacancy. And now, since electrons are negatively charged, the electrons leaving a site means a positive charge is developed there, and these positive vacancies are what we refer to as holes. Okay, so at room temperature we have sufficiently large number of free electrons, and suppose consider that one hole is present here, and it may so happen that this electron might get combined with this hole. So this process is known as recombination. For each free electron there is an associated hole, so that means the number of free electrons is equal to the number of holes. Okay, so that is how semiconductors are able to conduct electric current as we approach room temperature. So a hole is the absence of an electron in a particular place in an atom, as we just saw, and it is not a physical particle, but a hole can be passed from atom to atom in the same sense as an electron in a semiconductor material, because in an actual semiconductor material it's not the holes that are moving, it's the electrons that are moving from atom to atom. But you know, these two terms can be used interchangeably. And suppose let us consider a semiconductor material connected to an external voltage supply, and we have just seen here that semiconductors also conduct electric current at room temperature, and conductors also conduct electric current at room temperature. So what's the difference between the two? Now it's based on charge carriers. In a semiconductor, the electric current may be either due to flow of electrons or due to flow of holes. But in a conductor, the flow of electric current is always due to electrons. Fine. And semiconductors are of two types: intrinsic and extrinsic. And extrinsic semiconductors can be further divided into p-type and n-type, which we'll discuss in the next video. So that's it for today, guys. See you in the next lecture.